Here we have a indices problem. Now, people found this very hard when I asked my class to do this, but it shouldn't be. I think probably the reason why people found it hard is because they got a little bit too caught up with all this stuff over here. I mean, just ignore it. Another way of asking this question is just to simplify that thing, simplify this. Well, let's do that and see what we get. I mean, it's clearly not going to hurt to just start working on that and see if we can write it in a simpler way. But I'm spotting little things like here we have y on top and x underneath, and in the answer we have, well, the thing we're trying to work towards, we have x on top and y underneath. So somehow they must swap over. But oh look, there's a negative power here, which is exactly what that does. It flips a fraction. So, you know, you shouldn't be panicking about this. Just slowly start unpeeling the layers of the onion of this problem and see what comes up. So I'm just going to write out the original problem to begin with and think, what can we do first? Well, I don't really like the square root symbol. This is an indices problem, so let's write the square root as a power. Square root is power half. So notice that the outside brackets I've left alone, haven't touched. They've got the outside brackets and the big power -5. That's unchanged. But this square root symbol I've written as power half on that whole fraction. You do need the extra brackets inside. But then we've got an object, y over x, to a power, to another power. And when you've got something that's already raised to a power, raised to another power, you should know that you have to simply multiply those powers together. So let's multiply half by -5 to get the kind of resultant power. Excuse my dodgy arrow. So that's all we've done. We've got our object, our y over x, to the power of the product of these two numbers here, which gives us -5 over 2, or -2.5 if you prefer. Okay, I think all that remains really is to deal with the negative. We've got a negative power, that tells us to flip the fraction over and get rid of the negative. And then we're done, really, because when you've got a fraction raised to a power, you can just apply that power to the top and the bottom separately, which is exactly the form that we're working towards, and therefore m is 5 over 2, and that's your final answer. You might wonder why it says where x is not equal to y here. Well, acknowledging that doesn't actually affect what we do in any way. It's just there to make the question feasible in the first place. Because if x was equal to y, then m could actually technically be any number. Because you'd have 1 to the power something over 1 to the power something, and it's just going to be 1 anyway. So actually, if it doesn't say x is not equal to y, then m could be anything. But if x is defined as not being equal to y, then m is specifically this number here. Sorry, it's just this number here. So just don't worry. Quite often there's this extra information that actually doesn't affect your process. So, you know, if necessary, just kind of cross things out and think, what would I do if the question ended here? And it just looks a little bit nicer if you cross out this stuff over here. So don't be afraid of doing that if necessary.